introduction. So I will start right off with two questions. First, who has heard the talk yesterday about Elektra? Is there someone? Okay, yeah, there's quite some, thank you. And who has heard of Elektra before this talk yesterday? Is there also someone? Okay, oh, there actually are. Oh, perfect. Okay, so yeah, I will directly dive in. So as you all know, reliable editing of configuration files is not so easy, or not always so easy. And this is not only a problem which is faced by configuration management, but is also a problem faced by applications themselves. In the moment they want to do integration and access other configuration files, they have basically the same problem as configuration management has. The focus of Elektra is wider than only to be used by configuration management because of this, but in this talk, configuration management will be the main focus. As you heard in the talk before, for example, OGEAs cannot access some files like YAML. And as you know, there are many incompatibilities between the different platforms. So the idea and the long-term goal of Elektra is to integrate the technologies as they are. And so we have a lot of brilliant parsers and validators out there which are waiting to be used. And the main goal is that configuration management and other tools should use exactly the same parsers as the applications do. So Elektra also introduces a specification language. I cannot go into detail during this talk, but things that can be done in this specification languages, you can specify which options are there, you can document them, you can specify which defaults are there. So if I remove the option, what does this actually mean if no option is there, and so on and so on. So all this information which is actually needed for doing configuration management should be in this specification. So that's the long-term goal of Elektra. And what also can be done because of this, you can also patch through. So for example, if you have here a configuration management tool, we will see this later then, you can patch this through to some specific file. For example, using the OGEAs parser and doing something, so you can decide which parts of the configuration maps to which parts of the configuration files. Okay, so to end this high-level overview, this technology integration can be used for configuration management, and the border is quite well defined. So Elektra is something which runs on the nodes, and the distribution between the nodes happens within the configuration management tools. So Elektra doesn't bother about this deployment, but it bothers about how the configuration works on the individual nodes. And the focus in the talk will be Puppet, but actually you could use Elektra with any configuration management tool. So I will talk today about not only one tool, about Elektra. This will be the first part, but also about Puppet-Elektra, which is basically a second project using Elektra. So let us start what Elektra is. So Elektra is a small, fast library. It doesn't have any dependencies, but it has many plugins, and these plugins have dependencies. It does not introduce a daemon, so it doesn't introduce any security problem. And its main abstraction we need for this talk today is the key value abstraction, which is the common structure amongst all configuration files. And yeah, any configuration file syntax is mappable to key value pairs. And yeah, with this abstraction in place, you do not have to care about the concrete syntax which is in use. So here we have example. So the same configuration is expressed in INI and also a little bit more verbose in XML. And these are some different parsers which are available in Elektra today. So there are also quite some bindings available. Yeah, so especially relevant is the Ruby binding, which we will use later for our Puppet integration. Okay, there are currently more than 80 plugins available within Elektra. A lot of them are involved in how to manipulate configuration files. Others are involved, for example, can check configuration for validity. And others, for example, can encrypt values within configuration files or can do completely different stuff. There are packages available for Elektra in various distributions. And yeah, it's already used widely in proprietary software. And yeah, for example, yeah, here's some examples. Yeah, but from the beginning of Elektra, the goal was to be used by the FLOSS ecosystem. So I'm here to push this a little bit forward. And there was a lot of positive response in the talk yesterday. So I'm looking forward to see many more applications electrified soon. Okay, so the second part will be this Puppet-Elektra module. So it basically adds two resource types within Puppet. They are called KDB key and KDB mount. And what they achieve can be shown here. So we have this compiled catalog, which is distributed to the nodes, and the Puppet agent then uses the libelektra core. And this KDB mount resource type defines this mapping. So we add new, we have new kinds of identifiers, which are called the keys, and we can map these keys with concrete files on the disk and with concrete formats. For example, with INI. So that's the KDB mount abstraction, so this mapping here. And then we have the KDB key, which can manipulate individual values within these files. So these are the two main abstractions. And the main idea in the Puppet-Elektra is to have configuration settings as first-class citizen, so that we are not manipulating complete configuration files, but we go down to individual configuration settings. And the goal of the project is to bring all features from libelektra to Puppet. So all the parsers Elektra has, the error messages that are provided by Elektra, and so on. So how does it work? The KDB key, so as you know in Puppet, you need here a unique identifier. And luckily, Elektra exactly has this unique identifier. Every key from Elektra is a unique identifier for a concrete configuration setting. So we directly write it here, and yeah, we automatically fulfill a Puppet property with it. Yeah, then we have the standard syntax. We can ensure that something is present, and then we can set a work group name. So here we actually added the Samba configuration and set a specific work group. So it's as simple as that. That's, of course, so Elektra does not manipulate any other settings. So the rest of the Samba configuration stays completely untouched. And if we want to be sure that some value is not there, so it should be the default, then we can ensure its absence. Okay, the larger goal of Elektra, as already said, is that application developers directly use Elektra. And in this case, nothing needs to be done. We would just write to this path, and the December configuration file would be edited. Of course, we have to bootstrap to get to this situation. And if applications do not already use Elektra, we can mount them. And for example, this here mounts the Samba configuration file. So we say at this Elektra key, we want to have this configuration file present. And here we can specify a list of Elektra plugins to do so. Okay. And if we can even go further. We can also add a specification, because in Elektra it also has a specification language included. And they can also written down directly in Puppet. For example, here we can define simple checks. For example, a type with short and some range. Which is actually then not part of the configuration file, but it will land up in a specification namespace of Elektra. And here, this is more than imperative Puppet code can do, because we can also have local checks. So these checks happen local on the node when before writing out the configuration. For example, we can check if a file exists in a trivial way. Okay, so is even more comfort possible because it's tiresome to manually encode these configuration constraints. And we also have a lot of implicit checks. Some plugins already know how their data look like. And here's one of the strengths of Elektra. For example, from how hosts file look like, we automatically know which parts are IPv4 addresses and IPv6 addresses, and how canonical host names look like. And if you use the hosts plugin, as done here, the Caribou mount, the host plugin actually recommends global network, so that's not really necessary to write it down. It's only here to see the larger picture, that more than one plugin is involved to do this. And then we get a complete a check for that we only write a valid hosts file. So if we have here an invalid IP address, if this master IP address is invalid, we will get a validation on the node where get address info will be invoked, and it actually check for this operating system if this IP address can be successfully resolved. And otherwise we get an error message from what get address info says about the IP address. And again, the long-term goal is that application developers, because they know best what configuration actually expect, should write the specification. And it's really simple, because also the specification is in key value pairs. You simply say this is an IPv4 address, and basically you have already encoded all the information we need to know. So what we actually want, we want to go beyond DevOps. So okay, of course it's nice if you have a group of developers and operations working together, but yeah, it's not always possible. And the longer term goal is that we have a common language to speak between developers and operations, so that we can communicate more efficiently what we expect as valid configuration. Okay, so the last part will be a case and a user study where this Puppet-Elektra was used. And first we have done a case study And in the case study, we basically set up the whole infrastructure of libelektra. So there's this web server, then documentation server, many DNS aliases and so on, and also a complete build server, continuous integration and so on. And all these parts were realized with Puppet-Elektra. Yeah, some of these applications directly use Elektra. Then it's of course quite trivial to apply Puppet-Elektra. In two cases, Bernhard was the one who implemented the Puppet-Elektra and did this case in the user study. And he also implemented, for example, two Ruby plugins which parse and write configuration files. Okay, then a little bit more information about the user study we did. Yeah, we had 4 Puppet tasks in 3 different variants, and the Puppet tasks were non-trivial. So you have to manipulate different configuration files in different ways, and the focus was on configuration file editing. And we compared the usability between KDB key, the one Puppet provider I talked before, then Augeas, ini settings, and host. And yeah, and we also did time measurements. So the setup was quite sophisticated and robust. Also participated in the study, and for example David, who will have the next talk, also helped us a lot and also participated with the study. Thank you a lot for that. Yeah, and if you worked with this system, you really saw that there was a lot of effort invested. And doing this setup, we measured how long editing of configuration files needed. And in the first task, we had host file editing, like shown here. And in the second part, we had modified Samba configuration. And yeah, so here these are the median values, and this is a box plot. So if this percentile 25 and 75, and these are the outliers here. So this already gives a quite clear picture, but we also used statistics to show if there's a significance, and it actually was. So the host is significantly faster than Elektra, so it actually pays off even with Elektra to write dedicated resource types. Then the ini settings was on par with Elektra, but as you know, ini settings is not generic, it only works for ini. Yeah, and for maintenance tasks, there was not a clear conclusion. Yeah, we also asked about the usability of the systems. We asked in a questionnaire to rate the usability of the systems, what is best and to what is worst. And also here, the specialized host plugin was liked most. ini settings and Puppet-Elektra are second best to use here. Okay, so at the moment we have a usable solution, as shown with the complete libelektra.org infrastructure works with this. And for example, with Puppet 4 and Debian Stretch, we have a very reliable solution. But on other systems, for example, the Ruby interpreter, not of the system, but another one is used. And here a Ruby gem would help, which does not exist at the moment. And so it is still maintained. So Bernhard is still agreed to maintain it, and I'm also a co-maintainer. But it would be great to have help and bring this tool forward. Yeah. Then there is this multi-key support. So Elektra by itself has transactional support for configuration files. So you can make a large change of many configuration files, and Elektra makes sure either all configuration files are changed or nothing happens. But in the current implementation, every KDB key makes an individual invoke within Elektra. And but for some plugins like Augeas, you can't go far if you need a single, if this is separated. So multi-key support would be great, and we hope to, the problem was in actually implementing it in a Puppet provider, and we hope that there's a better support from Puppet. But maybe we hear something about in the next talk. So here a picture of some of the people working on Elektra. So this is Bernhard who did the work. He could not come here, unfortunately. Thomas is here. We will wait afterwards outside. So if you want some T-shirts or stickers and want to talk with me, I will be outside afterward. So this is a more complete list of people currently working on Elektra on many topics. I can't go into the details of this. Here you can find the Puppet libelektra, and here you can find Elektra, and we also have all the data available of this user study. And so are there any questions? Okay, so the question was, if I have this validation already in the application, let's say if there is some way to export it to Elektra without defining it on two places. That's a really good question. And the goal of Elektra is to have it only at one place. And the current solution of Elektra is that if you have already specified in the Elektra, you can generate the core code you need in the application. So Elektra has also a code generator where you can put everything within the application. Yeah, so thank you. Is there another question? I think it's in a private repo currently because I think the data of the persons participating in the Puppet. So you mean this Puppet controller and this Docker thing? I think that's currently in the same repo, and we cannot publish it because it has non-anonymized person data. But on request we can separate it and give you this. So please drop me an email. Thank you. It's a good idea. Yeah. Are there some other questions?
Okay, let's give it up for Marcus.
Yes,
Okay, so 5 minutes, come back, we'll have David. Go. Okay, great, man, thanks.
Thank you. So see you outside.